Class 10, Science, Chapter 1, Chemical Reactions and Equations. Oh my God, there are so many reactions in chemistry. How am I going to learn all these reactions? Is this the thought going on in your mind right now? Hello children, in this video, we will try to simplify your problem by visualizing chemical reactions in an interesting way. Since there are so many reactions, we are going to classify them into 5 important types. You will also learn how to predict reactions based on these types so that you won't have to memorize all the reactions. Before proceeding further, let's have a quick recap of what you have learned in this chapter earlier. You already know what are chemical reactions, characteristics of chemical reactions, how to represent chemical reactions in the form of chemical equations, balancing a chemical equation. At the end of this video, I would be providing a few useful links which would help you to understand the concepts better. Now, starting with types of reactions, the learning objectives are to identify and classify different types of reactions, to predict reactions based on their types, application of chemical reactions in everyday life. Chemical reactions can be divided into 5 important types. In this video, we will look at each of these types and their examples. First, let's start with combination reactions. In combination reactions, 2 or more substances combine to form one single substance. Let's say we have 2 reactants A and B. They combine to form one single product AB. For example, hydrogen combines with oxygen to give water. The equation can be written as H2 plus O2 gives H2O. Note that the product is not a simple join of the formula of the reactants. So it's not H2O2, it's H2O because the elements combine according to their valency. The balanced chemical equation can be written as 2H2 plus O2 gives 2H2O. Remember children, the equations you write should always be balanced. If you have any doubts in writing the chemical formulae of compounds and balancing equations, you can refer to the links provided at the end of this video. In this simple reaction, the reactants were elements and the product was a compound. But the reactants can also be compounds. Let's take an example. In the reaction where carbon monoxide combines with oxygen, carbon monoxide is a compound and oxygen is an element. And when they combine together, they form carbon dioxide. The balanced chemical equation can be written as 2CO plus O2 gives 2CO2. Now, why don't you try predicting the next reaction? Hint, it's a combination reaction. Sodium and chlorine combine to give. The correct answer is sodium chloride. The equation can be written as Na plus Cl2 gives NaCl. The balance equation is 2Na plus Cl2 gives 2NaCl. Let's put combination reaction on our concept board. The key point is only one product. Next, let's look at decomposition reactions. Decomposition reactions are the opposite of combination reactions. In decomposition reaction, one compound breaks down into 2 or more simpler substances. A substance AB decomposes or breaks down into 2 substances A and B. Remember, in decomposition reaction, you have just one reactant but 2 or more products. The decomposition reactions take place when energy is supplied in the form of heat, electricity, or light. The decomposition reactions can be further divided into 3 types. The first type, electric decomposition or electrolysis. When a substance is decomposed by passing electric current through it, it is known as electrolysis. Example, water on passing electricity breaks down into hydrogen and oxygen. The equation can be written as 2H2O on passing electric current breaks down into 2H2 plus O2. The next type of decomposition reactions are thermal decomposition reactions. When a substance decomposes on heating, it is called thermal decomposition. For example, calcium carbonate on heating gives calcium oxide plus carbon dioxide. The equation is CaCO3 on heating gives CaO plus CO2. The next type of decomposition reactions are photochemical decomposition reactions. When a substance is decomposed in the presence of sunlight, it is called photochemical decomposition reaction. Here we have two examples. Silver bromide in the presence of sunlight gives silver plus bromine. Silver chloride in the presence of sunlight gives silver plus chlorine. The reactions can be written as 2AgBr in the presence of light gives 2Ag plus Br2. 2AgCl in the presence of light gives 2Ag plus Cl2. This reaction is used in black and white photography. This concept is very important as this is a frequently repeated question in your board exams. Now, can you predict what type of reaction is digestion of food in our body? Is it a combination reaction or a decomposition reaction? The correct answer is decomposition reaction. Our digestive system breaks down the complex food substances into simpler substances. Carbohydrates are broken down into simpler sugars such as glucose. Proteins are broken down into amino acids and fats decomposed to fatty acids and glycerol. Let's now pin decomposition reactions on our concept board. Remember the key point, only one reactant. Now let's look at displacement reactions. In displacement reactions, a more reactive element displaces a less reactive element from a compound. These reactions are also called single displacement reactions or substitution reactions. Here, A is more reactive than B, so it displaces B to form the product AC. Let's take an example. Zinc displaces copper from copper sulfate solution because zinc is more reactive than copper. In the next example, we have 2AgNO3 plus Zn gives 2Ag plus ZnNO3 twice. In the above reaction, zinc is more reactive than silver, so zinc displaces silver from its solution. How do we know which element is more reactive than the other? In chemistry, we have a reactivity series. This is the reactivity series of metals. Metals on the top are more reactive, and as we go down the reactivity series, the reactivity of metals decreases. Hydrogen is also on the list, though it's a non-metal due to its electropositive nature, and it can be displaced by metals. Children, here I am sharing an interesting mnemonics for you to remember the reactivity series of metals. किरण ने कार मांगी ऑल्टो जेन फरारी फिर भी हाय क्यों मिली सिल्वर ऑडी. आई एम रिपीटिंग इट वंस मोर. किरण ने कार मांगी ऑल्टो जेन फरारी फिर भी हाय क्यों मिली. मिली is for mercury here. Silver ऑडी. I shared this mnemonics in the lesson notes of this chapter. Now, can you predict what happens when an iron nail is dipped in copper sulfate solution? You got it right. Iron is more reactive than copper, hence it displaces copper from copper sulfate solution. The reaction can be written as Fe plus CuSO4 gives FeSO4 plus C. The blue color of copper sulfate solution becomes green due to the formation of iron sulfate, and a reddish brown deposit of copper is formed on the iron nail. Now, what happens when a copper rod is immersed in iron sulfate solution? Of course, no reaction takes place, as copper is less reactive than iron. Children, you will see that in the reactivity series, copper is below iron. So, being less reactive than iron, it cannot displace iron from its solution. Let's put displacement reaction on our concept board. The key point, a more reactive element displaces a less reactive element. The fourth type of reaction is double displacement reaction. In double displacement reactions, two compounds react with each other and exchange their ions to form two new compounds. Let's say we have two compounds A, B and C. After exchange of ions, they form two new compounds as products AD and BC. Do we need to use the reactivity series again for double displacement reactions? The answer is no. The reactivity series is only used for single displacement reactions. In double displacement reactions, we cannot say whether A displaces C or C displaces A. It is simply a mutual exchange of ions. Let's see an example of double displacement reaction. Barium chloride reacts with sodium sulfate to form barium sulfate and sodium chloride. The reaction can be written as BaCl2 plus Na2SO4 gives BaSO4 plus 2NaCl. First, split the reactants into their constituent ions. We can exchange either the cations or the anions. We should not exchange both the cations and anions, or else we will get back the original reactants. Now, can you predict, are neutralization reactions and precipitation reactions examples of double displacement reactions? The correct answer is yes. Neutralization reactions and precipitation reactions are examples of double displacement reactions. Let's see. Precipitation reaction. The reaction in which precipitate is formed by the mixing of the aqueous solution of two salts is called precipitation reaction. Example, silver nitrate combines with sodium chloride to give silver chloride and sodium nitrate. The reaction can be written as AgNO3 plus NaCl gives AgCl plus NaNO3. Here, silver chloride or AgCl is the precipitate. Neutralization reaction. The reaction in which an acid reacts with a base to form salt and water by exchange of ions is called neutralization reaction. In the reaction, hydrogen ions and hydroxide ions combine to form water. A salt is the product of an acid-base reaction. For example, hydrochloric acid reacts with sodium hydroxide to give sodium chloride and water. The reaction can be written as 2HCl plus NaOH gives, HCl plus NaOH gives NaCl plus H2O. In the above reaction, NaCl is the salt. The reaction is already balanced. Now let's spin double displacement reaction on our concept board. The key point here is exchange of ions. Now let's look at the fifth and final type of reactions, redox reactions. Redox stands for reduction and oxidation. In these reactions, one substance is being reduced and the other is being oxidized. Let's see some examples. In the first example, iron oxide reacts with carbon monoxide to give iron and carbon dioxide. Here, iron oxide gets reduced to iron and carbon monoxide gets oxidized to form carbon dioxide. In the second example, we see that carbon combines with oxygen to give carbon dioxide. Carbon is oxidized to carbon dioxide and oxygen gets reduced. First, let's understand the meaning of oxidation and reduction. Oxidation is addition of oxygen or removal of hydrogen or loss of electrons. Any chemical substance following any of these rules is said to be oxidized. Reduction is removal of oxygen or addition of hydrogen or gain of electrons. Any chemical substance following any of these rules is said to be reduced. Here I am sharing another interesting mnemonics for you to remember oxidation and reduction. Oxidation is loss of electrons and reduction is gain of electrons. You will learn this concept in higher classes. You can easily remember this with the help of an interesting mnemonics. Leo the lion says Gar. Leo stands for loss of electrons in oxidation and Gar, spelled as GR, stands for gain of electrons in reduction. I have shared this mnemonics in the lesson notes. Remember, always the reactants get oxidized or reduced and not the products. Let's see now what are oxidizing and reducing agent. This is another important concept which is frequently asked in your board exam. Substances that get oxidized are called reducing agents. Substances that get reduced are called oxidizing agents. Oxidizing agents give oxygen to another substance or remove hydrogen from it. Reducing agents remove oxygen from another substance or give hydrogen to it. In this example, iron oxide reacts with aluminium to give aluminium oxide and iron. We can see that iron oxide is the oxidizing agent, but it itself gets reduced, whereas aluminium is the reducing agent and it itself gets oxidized. Let's spin redox reactions on the concept board. Remember the key point, reduction and oxidation are both taking place. I hope that all the 5 types of reactions are crystal clear to you. So next time you see a chemical reaction, I would encourage you to fit it into one of these types, and that would help you to predict the reaction. So you don't have to memorize all the reactions. What do you see on this slide, children? Right, this is the process of photosynthesis. We know that green plants take energy in the form of sunlight to perform photosynthesis. Can you predict what type of reaction is this? Based on the energy changes involved, chemical reactions are divided into 2 more types. Endothermic reactions. Endothermic reactions absorb energy in order to proceed. This required energy can be provided in many forms, but it is typically in the form of heat or light. For example, photosynthesis is an endothermic reaction because plants take up sunlight in the form of energy, or they absorb sunlight. Decomposition of calcium carbonate is also an example of endothermic reaction in which heat is required. We have already discussed this reaction in decomposition reactions. The next type of reactions are exothermic reactions. These reactions also involve energy changes. An exothermic reaction is a chemical reaction that releases energy in the form of light or heat. It is the opposite of an endothermic reaction. Expressed in a chemical equation, reactants give products plus energy. For example, calcium oxide combines with water to give calcium hydroxide plus energy. The reaction can be written as CaO plus H2O gives CaOH twice plus energy in the form of heat. We can feel the heat produced in the reaction. What do you see on this slide? Right, this is the process of respiration. What type of reaction is this? Respiration is an exothermic reaction. Let's see why. In the process of respiration, the simpler molecules of food are oxidized to give carbon dioxide, water, and energy. We know that a reaction in which energy is released along with the formation of products is known as an exothermic reaction. Thus, we can conclude that respiration is an exothermic reaction. Let's see the effects of oxidation reactions in everyday life. Corrosion. The process of slow conversion of metals into their undesirable compounds due to their reaction with oxygen, water, acid, gases, etc. present in atmosphere is called corrosion. Corrosion causes damages to car bodies, bridges, iron railing, ships, and to all objects made of metal, especially those of iron. Corrosion of iron is called rusting, and it's a serious problem. Every year, an enormous amount of money is spent to replace damaged iron. The rusting of iron can be prevented by painting, oiling, alloying, galvanizing, anodizing, etc. Galvanization is a method of protecting steel and iron from rusting by coating them with a thin layer of zinc. Another effect of oxidation in our daily life is rancidity. The taste and odor of food materials containing fat and oil changes when they are exposed to air for a long time. This is called rancidity. It is caused due to oxidation of fats and oils present in food materials. Let us see how we can prevent rancidity. Storage in colored glass containers prevents oxidation of fats by rays of light, thus preventing rancidity. Storing food in airtight containers also prevents food items from becoming rancid. Vacuum packaging retards rancidity by excluding oxygen. Replacing air by nitrogen also prevents rancidity. This you can see in your chips packets. Naturally occurring antioxidants like vitamin C, B-carotene, and vitamin E protect against rancidity. Refrigeration of foodstuff also prevents rancidity. That's all, children. Here are a few questions to assess your learning. I have provided some important links. The first link will be helpful how to learn chemical formulae. The second link will be helpful in learning to balance chemical equations. In the third link, there are some important activities of the chapter which are presented in an interesting way. Thank you, children. If you have any doubts, please put it on the comment box and I will try to get back to you as soon as possible. Thank you once again.